Welcome to Maths with Mrs. V. In this lesson, we're going to continue looking at functions and inverses. In the previous lesson, we looked at what an inverse is, and now we're going to look at the definition of a function. So at first, we're going to start with the straight line function f of x is equal to x plus 1. This is written in function notation. That's why we can put the f of x there, and we'll get into more of that later. But for now, I plotted this graph so that you can see what it looks like. If we take any value in the domain of x, it's easy in this case because x is an element of real numbers, so we can choose any number. So I'm just going to choose the number 1, and I'm going to put the number 1 in place of x here so that I can get an answer for y. So I'm going to map that onto my y, which is my range, and so if I say 1 plus 1, I get 2. Then if I choose any other number, let's choose 2 for example. If I map that onto my range, I'm going to get 2 plus 1 is 3. And we can keep going, we can go as far as we like, and I can do as many examples as I want, and each time we're just going to add 1. For every input value, we have a unique output value. So every time we have a different x value, we get its own y value. It doesn't give us 2 different values, it only gives us one answer. And so that is what we call a 1-to-1 function. And when we have our function being mapped to only one value, that is when we can actually call it a function. So the formal definition of a function is that every input has a unique output. We can use what's called the vertical line test to have a visual representation of whether a graph is a function. So if you draw a vertical line and that line crosses your graph only at one point, then it is a function. So you can put that line at any point along your graph and see whether it crosses at one point, and that means it is a function. The vertical line test is not a definition for a function, it's just a visual representation. The definition for a function is that every input value has a unique output value. If I now want to go and reflect this graph about the y equals x line, I can work it out by doing my switch around. So I'll have y is equal to x plus 1, and then that will go to x is equal to y plus 1, and so my graph will be y is equal to x minus 1. And if I draw this graph onto the Cartesian plane here, you'll actually see that these graphs are all parallel to each other, so they won't intersect. That's fine. But now what I want to show you is that if we do the vertical line test for the new graph, we can see that it also touches the graph only at one place every time we use the vertical line test. So we can do it at any point, and it's only going to cut the graph at one point. That means that my new graph is also a function. And so what we can do is we can use function notation now for this as well. But because it's the inverse graph, what we do is we use a superscript of -1, which doesn't mean to the power of -1. It's just a notation for the inverse graph. And then that is going to be a function of x, and it's going to be x minus 1, which is the graph that I found when I did the inverse. So now instead of writing y is equal to x minus 1, because I know that it's a function, I can use function notation, and I also know that I've worked it out as an inverse, and so I use f to the -1 of x is equal to x minus 1. Let's have a look at what happens with the parabola. So I've plotted the parabola of x squared here, and if we do a vertical line test just to see straight away, we can see that if we do the vertical line, it will just pass the graph at one point, and we can do it somewhere else as well, and we can see that it will also just pass the graph at one point. So we know that it is actually a function, but let's go and see what happens and how this is different to the straight line. So if we put in a value of 1 and we square that for x squared, we're going to get out an answer of 1. And if we had to do 2, we get an answer of 4. But what about if we put in -1? We also get an answer of 1. And if we put in -2, we also get an answer of 4. So now we have the same y value coming out, even though we've put in a different x value. This still fits the definition of a function because for every x value, we get only one answer for that particular x value. A different x value could yield the same answer, but because it's a different x value, it still fits the definition of a function. And we call these types of functions many-to-one functions. Now let's go have a look at the inverse function for x squared. So if we go and do our process of changing it to y equals x squared, and then we can switch around the values and we get x equals y squared, and then we end up with y is equal to plus or minus the square root of x. And this is in fact a parabola, but it is in a different direction. So I'm just going to sketch it in here. It's basically on its side like that. And so if we have a look at this parabola and do the vertical line test here, we can see that if we put a vertical line anywhere along this graph, that it's going to cross over the graph in more than one spot. And immediately that tells us that we now have a graph that is not a function. So we cannot use the function notation to represent this graph. We just leave it as y is equal to. And we call these types of graphs one-to-many graphs. So here are some more one-to-one graphs. We've had a look at the straight line. If we do the vertical line test, we can see it only touches at one point, and so that is a function. We then also have the hyperbola. If we do the vertical line test, at any point on the graph, we have a vertical line that only crosses at one point, so that is a function. And the exponential graph is also a function because it passes the vertical line test. Let's have a look at these graphs. The parabola, we've seen that we can also get it to pass the vertical line test because it only crosses the graph at one point anywhere on the graph. And then this graph here is a sine graph, and we can see that that also crosses the graph at one point. But these two graphs are many-to-one graphs because if we put a horizontal line, we actually cross the graph at more than one point. That makes it a many-to-one graph. So in this case here, we have many points that cross on the horizontal line. These are not functions because it does not pass the vertical line test. So a circle crosses at 2 points, so that's many points that it crosses on the vertical line, and it also crosses at many points on the horizontal line. So these graphs are called many-to-many graphs. So for each of these, whether we put a vertical line or a horizontal line, we will see that those are many-to-many graphs. And then this last one at the bottom, it is not a function, so it has many points that cross on the vertical line, but if we put a horizontal line, it only has 1 point. So this is actually a one-to-many graph. If you found this lesson helpful, please like and subscribe.